right, y'all, we're starting a new unit today on circles. We are going to be starting with our vocab, and this is like going to be your best friend. So if you ever don't know what something is, this is what you're going to want to reference to make sure you're talking about the right thing. So we're just going to talk about the vocabulary before we get into solving. So a circle, everybody knows what a circle is right here. This is a circle, and it's a set of points in a plane. So that means that a circle is going to be one-dimensional, equidistant from the given point called the. Well, all these points are equidistant from this right here, which is the center. Okay, all the points on a circle are equidistant from the center. So right here, how you name it by its center, and you're just going to say circle C. And you know that all the way around a circle is equal to 360 degrees. All right, number 2, a chord. We're going to be dealing with this a lot. We're going to be dealing with it today. A chord is a segment that is inside the circle. It has 2 endpoints, okay? And it just connects one side of the circle to the other. A chord does not have to go through the center. It just connects one side of the circle to the other. And we'll name this A, B. And the way you would name it, because it's a segment, you just name it, say, segment AB, okay? A chord is basically a segment within the circle that has 2 endpoints. All right, a radius. We know what a radius is. A radius is a segment with one endpoint at the center of the circle and another endpoint just somewhere on the circle or on the edge of the circle. So a radius, it has to go through the center and it has to connect to the edge of the circle, okay? It is a segment. So this is point A. We would just name this segment AC, okay? A radius, what you need to know that's important about a radius is it's equal to half of the diameter. We're going to say D stands for diameter, okay? Okay, if a radius is half of the diameter and it just goes halfway across, the diameter is going to be the whole segment. It's going to go all the way across, okay? The chord containing, so a chord, it's going to have 2 endpoints, and it's going to contain the center of the circle. So the diameter is a chord that goes through the center. And if we name this AB, the diameter would be segment AB. And if the radius is half the diameter, double the radius would be equal to the diameter. That's just another way of saying the radius is half. Either way. Okay, a tangent is a line that intersects a point. A line that intersects a circle at exactly 1 point, okay? So it can't have 2 points on this circle. It can have exactly 1. So a tangent basically hits the edge of a circle at exactly 1 point, okay? And it's a line, so that means it goes on forever in both directions. So we're going to name it, we're going to put 2 points on it. It can have as many points as you want, but we're going to name it line AB, not segment, because a tangent is a line, not a segment. Okay, secant is a line that intersects a circle at 2 points, okay? So if it intersects and it's a line, it means it's going to go through it. It's not a chord, which would be a segment, but it's going to go through it because it's a line. So we're going to put 2 points, and it's going to go through it because it's a line. It's going forever in both directions. If we call it AB, it's also going to be labeled line AB. So secant really is just a chord that's a line, or a chord is a secant that's a segment, whichever way you want to think about that, okay? All right. We're going to stop there with vocabulary for today. That's all you need to know for vocabulary for today. So hold on to that because we're going to be coming back to that whenever we do different parts. But today we talked about basically diameter, radius, chord, secant, tangent. I think that's it. And that's what we're going to be using today. So when we talk about special segments in a circle, we're talking about chords, which is a segment in a circle. We're talking about tangents, which is a line that intersects at exactly 1 point. And we're talking about secants, which is a line that intersects at 2 points. Really important, a chord is a segment, and secant and tangent, those are lines. Okay, so here's what you need to know. Whenever you have two chords that intersect, if you multiply the segments of one chord, it's going to be equal to the distance if you multiply the segments of another chord. So right here, AB multiplied together is equal to CD, okay? That can help you find distances in a chord. If you have two secants, which are two lines that would intersect a chord, you can multiply the outside segment times the sum of the whole segments of the secant, and that's going to be equal to the outside segment of the second secant times the segments added together. These are all just formulas that you'll need to know. Okay? And if you have a tangent and a secant, and the tangent is what intersects at exactly 1 point, you will have that the tangent squared, because we know this line is a tangent because it intersects at 1 point, is equal to the segment of the secant times the sum of the segments of the secant, okay? I know that's just a lot of formulas going on and a lot of vocabulary going on, but we'll start to use it more and you'll get more comfortable with it. So, if we start at number 1, it says find the value of x. Well, right here it told me that if I multiply the segments of the chords together, they're equal. So I know x times 9 is going to be equal to 6 times 3. 6 times 3 is 18. X times 9 is 9x. Divide both sides by 9 and you'll get x equals 2. Okay? Same idea on number 1, that if I multiply the parts of my chord together, they'll be congruent. Be careful. You have to multiply parts that are on the same chord. X and 8 are not on the same chord, so I can't multiply them together. So I have to multiply 8 times 6, and that will equal x times 2.5. 8 times 6 is 48. X times 2.5 will be 2.5x. Divide both sides by 2.5. And you'll get x is equal to 19.2. Y'all, you can always go back in and double check. Okay, so when we go back in, we can see that if we multiply 2 and 9, we get 18, and 6 and 3, we also get 18, so those are congruent, okay? You can always just go back in and double check to solve. All right, number 3, we have 2 secants, so that's going to be case number 2, and we know that the outside times the sum of the secants is equal to the outside times the sum of the sequence. So the way I set this up, I just substituted it into this formula here. So now I'm just going to simplify what's in my parentheses. Well, 9 times 20 is 180. Is equal to 10 times 10 plus x. 2 ways to do this. You can either distribute your 10 and solve, but you're basically going to have to undo that work. So right here, I know this 10 is being multiplied, so I can divide both sides by 10. 180 divided by 10 is 18, and I'll say that is equal to 10 plus x. Subtract 10 from both sides, and I get x equals 8. Okay? Number 4, same case, you have 2 secants, and I know that the outside times the sum of what's in the inside, so 3 plus 8, is equal to the outside of my second secant times the sum of the inside. I'm just going to simplify. 8 plus 3 is 11. I'm going to leave this here. I could distribute, but I'd basically be undoing your work. If you want to distribute, go for it. 3 times 11 is 33, and that is equal to 4 times x plus 4. Okay? So I can divide both sides by 4. I'll get 8.25 is equal to x plus 4. Okay? I can subtract 4 from both sides. And I'll get x is equal to 4.25. All right, I'm going to show you that distributing would give you the exact same answer. So right here, sorry y'all, that's really gross. Right here I have 33 is equal to 4x plus 4. So if I distribute that, I'd get 4x plus 16. Well, 33 minus 16 is 17. If I set that equal to 4x, I'll have to divide 17 by 4, and 17 divided by 4 is 4.25. Two ways to do it. They give you the exact same answer. All right, number 5. I have a tangent and a secant. I know the formula up here tells me that the tangent squared, so this 10 squared, is equal to the outside segment times the sum. So my outside segment is 5, and the sum would be 5 plus x. I'm just going to come in and simplify. I know 10 squared is 100, and I'll get 5 times 5 plus x. Again, two ways to do it. You can distribute or you can divide. I'm going to divide both sides by 5, and I'll get 20 equals 5 plus x. I'll subtract 5 from both sides, and I'll get x equals 15. Okay? Same thing for number 6. I know the tangent, or that 7 squared, is equal to the outside times the sum of the secant. I know 7 squared is 49. And you can either distribute or divide. In this case, just to show you both options, I'm going to distribute. So you're going to get 49 equals 9 plus 3x. If you subtract 9 from both sides, you get 40 equals 3x. To get x by itself, you're going to divide 40 by 3. And you'll get 13.3 repeating, which is the same as 13 1/3. Okay? All right, flipping over to the back. Sometimes you're going to have to solve a quadratic equation. So sometimes we're not going to have the prettiest numbers when we are doing this. Okay, so you know how these on the front, they just simplified really easy. We didn't have any squared numbers. We didn't have anything crazy going on. Well, sometimes you're going to have a quadratic equation, and that means you're going to have an x squared term. So you're going to have to do some sort of solving to get x by itself, okay? If you were to graph a quadratic equation, you would get a parabola. Parabola. I think I spelled that right. Okay, so basically, these are just going to get a little bit more complicated, not as straightforward as what's on the front. So there's a bunch of different ways to solve quadratic formulas. So you always want to try GCF first. Always, 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 okay? If GCF doesn't work, there's a bunch of different ways you can do it. So we're just going to jump in and see where our memory is on solving quadratics. So number 7, we have 2 chords that are intersecting. So I know that if I multiply 3x and 5x, that should equal 10 times 12 because that's 2 chords that are intersecting. That's case 1 on the front. 3x times 5x is 15x squared. 10 times 12 is 120, okay? I can divide, you're just going to solve this like you normally would. I'm going to divide 120 by 15 to get that x squared by itself. I get x squared is equal to 8, okay? Well, how do you get x by itself? To get x by itself, you're going to take the square root of both sides, and you're going to get x is equal to plus or minus the square root of 8, okay? We know that we can simplify that square root of 8 by breaking it into its perfect squares of the square root of 4 and the square root of 2. So if we completely simplify it, x is equal to plus or minus 2 root 2, okay? Plus or minus because when you take the square root, you get 2 values, the positive value and the negative value, okay? Looking at number 8 is the same thing. You're going to multiply and solve. Number 9, we have a tangent and a secant. So I know that tangent squared, so the 6 squared is going to be equal to the outside, which happens to be x, times the sum of the insides. Okay? 6 squared is 36. In this case, I have to distribute my x. So I'm going to get 9x plus x squared. Okay? This right here, there's nothing I can factor out. There's nothing I can do to simplify it. So I want to move everything to one side to make it look like a quadratic that I'm comfortable solving with. You always want your x squared to be positive. So I'm going to move the 36 over, and I'll get 0 is equal to x squared plus 9x minus 36. I've just rearranged it so it's in standard form. Well, now I know how to factor this. I'm going to use magic number trinomial. So I need to figure out what multiplies to negative 36 and what adds to 9. Okay, so when we think about the factors of 36, we know that 6 and 6, but that doesn't add to 9. If we divide it by 12, we get 12 and 3. So I know that x plus 12 and x minus 3, that's going to add to positive 9 and multiply to negative 36. I'm going to set that equal to 0. I set both of my factors equal to 0, and I'll get x equals negative 12 and x equals 3. Okay? All right. Number 11. Same idea, but now we have two secants that are intersecting, and so I'm just going to follow the rule that the outside is equal to the sum of the entire secants. So the outside is equal to the sum of the entire secant. I'm just going to come in and simplify. I'm going to have to distribute in these problems. 4 plus 8 is 12. 4 times 12 is 48. Y'all, this again is a magic number trinomial. There's nothing I can factor. So I'm going to subtract everything over so my x squared stays positive. So I'm going to have x squared plus 2x minus 48 equals 0. X squared plus 2x minus 48. I can do magic number trinomial. So I know it needs to multiply to negative 48. And it needs to add to 12. Add to 2. And I know that a positive 8 and a negative 6 will add to 2, but multiply to negative 48. I set both of my factors equal to 0. I'll get x is equal to negative 8, and x is equal to 6.